So this week I have recorded the entire PowerPoint and you will have already found it here. This week we're going to focus on the structure of DNA. So you're going to be able to state what DNA is, describe its structure, and explain why DNA is so important. So back in 2013, there was a lot of talk around horse meat, and horse meat being in different supermarket burgers, lasagnas, and other meat products. But how was it possible to tell that there was horse meat in these products and not just beef? It was all to do with DNA. They were able to test for DNA because everybody's DNA is unique. To start, I want you to look through these statements and decide whether they are true or false. So you can either pause the video and do it or go back to the PowerPoint. And I will give you the answers next week. And you should be able to discover the answers as we work through this week and next week's PowerPoints. So, what makes organisms different? It's all to do with chromosomes and genes. You have got 46 chromosomes inside the nucleus of every one of your cells. So if you think back to the cells topic where we looked at the different structures that were in animal cells, we had the nucleus. Chromosomes are fine threads that carry bits of information about what you are like. These bits of information are called genes. Chromosomes and genes are made of a chemical called DNA. Each of your genes controls one or more of your characteristics that you inherited from your parents. The genes passed on from your father pair up with the genes passed on from your mother. The genes in a pair may carry the same message, but sometimes one of the genes carries a different message from the other. These are called gene alleles, different forms of the gene. These alleles are in competition with each other. Some alleles are dominant and some are recessive. When a dominant allele pairs up with a recessive allele, the dominant allele wins and causes the final effect. So before we learn about DNA, we first need to learn how it was discovered. So there are a few different people involved in the story of the discovery of the structure of DNA. In 2013, a letter written in 1953 by Francis Crick to his 12-year-old son was sold at auction for $5.3 million. Why was this letter so important? It was written by one of the biologists who was just about to reveal the structure of perhaps the most important molecule in living things, DNA. My dear Michael, the letter begins, Jim Watson and I have probably made a most important discovery. We have built a model for the structure of deoxyribonucleic acid. Read it carefully. It is called DNA for short. Our structure is very beautiful. It goes on to say, in other words, we think we have found the most basic copying mechanism by which life comes from life. Biologists knew that DNA was an important molecule, and for several years in the late 1940s and 1950s, there was a great race to work out the structure of the molecule. And the four people you see on the screen here, Rosalind Franklin, Francis Crick, James Watson, and Maurice Wilkins, were at the heart of that race. The molecule they described is shown here. It is a long spiral molecule called a helix. Since it has two strands in the spiral, it is called a double helix. On the outside of the molecule, the two strands called the backbone, which run the length of the molecule, and between the backbone are the base pairs, which looks like the rungs of a ladder. The whole molecule looks like a twisted ladder, and we're going to look at this in a bit more detail later on. In 1951, Franklin was offered a 3-year research scholarship at King's College in London. With her knowledge, Franklin was to set up and improve the X-ray crystallography unit at King's College. Maurice Wilkins was already using X-ray crystallography to try to solve the DNA problem at King's College. Franklin arrived while Wilkins was away, and on his return, Wilkins assumed that she was hired to be his assistant. It was a bad start to a relationship that never got any better. By the end of her 3-year research scholarship, Franklin was able to get 2 sets of high-resolution photos of the crystallized DNA fibers. She presented her data at a lecture in King's College at which James Watson was in attendance. In his book, The Double Helix, Watson admitted to not paying attention at Franklin's talk and not being able to fully describe the lecture and the results to Francis Crick. Watson and Crick were at the Cavendish laboratory and had been working on solving the DNA structure. Franklin did not know Watson and Crick as well as Wilkins did, and never truly collaborated with them. It was Wilkins who showed Watson and Crick the X-ray data Franklin obtained. The data confirmed the 3D structure that Watson and Crick had theorized for DNA. In 1953, both Wilkins and Franklin published papers on their X-ray data in the same Nature issue with Watson and Crick's paper on the structure of DNA. In 1962, Watson, Crick and Wilkins jointly received the Nobel Prize in Physiology or Medicine for their 1953 determination of the structure of DNA. Wilkins' colleague Franklin, who died from cancer at the age of 37, was not so honoured. The reasons for her exclusion have been debated and are still unclear all these years later. On this slide you'll find a short YouTube video that I've made about DNA structure. It will take you through the basic structure of DNA, the sugar phosphate backbone, and the 4 different bases and how they all join to make the double helix structure. This week's assignment is just a short multiple choice on Teams. As it's an in-service day on Friday, this will be due on Thursday at 12 o'clock. This will give you some time to catch up on any previous assignments you may have missed. And make sure at the end of this you review your success criteria and check that you have successfully completed them all. If you have any questions, please just let me know.